Welcome to all. I am Nagarajan, Assistant Professor of Physics, Government Pursuit College, Kolar. This is about Bangalore North University, third semester BSc Physics, paper 301, Electricity and Magnetism. The learning objective of this session is to study the concept of force on a current carrying conductor in uniform magnetic field. So after completion of this session, one can easily follow the calculation of force on a current carrying conductor in uniform magnetic field. This is a method to find the force on a current carrying conductor in uniform magnetic field. So to find out this, we have to consider a conductor of length L. This is a conductor of length L carrying current I from left to right. And A is the area of cross section of the conductor. Let I be the steady current. I already explained I is the steady current flowing through the circuit. So let this conductor be kept in a uniform magnetic field B. This conductor is kept in a uniform magnetic field B, which is along the plane of the paper and upwards. The current in a metal wire is due to the free electrons. The current in this metal wire is due to the free electrons. So let N be the number of charge first per unit volume of the conductor. Then the number of charges in a volume element, that means in the small element of volume dV is equal to N into dV. The force dF due to this charges is given by dF is equal to N dV into Q vector V cross B. So where this quantity Q V cross B is the force on charge Q which is moving with a velocity V. Since the current I is steadily, that means it is a steady current, all the charges are assumed to move with the same velocity V. Due to the steady current, all the charges are assumed to move with the same velocity. Then this dF is equal to N into QV cross B into dV. So we know the current density J is equal to NQV. So then this equation becomes dF is equal to J cross B into dV. But the volume element depends on the area of the conductor and also the length dl. Therefore, dV is equal to A into dl. A is the area, dl is the length. So then, this equation 1 becomes dF is equal to J cross B into AL. But we know the definition of current density J is equal to I by A. So then dF is equal to IDL cross B. Therefore, the total force acting on the conductor of length L is obtained by integrating this. So if we integrate this, we will get the total force acting on the conductor of length L. So integration of dF is F and integration of this is, this we can write integral of IDL cross B. So the integral of this is I into L cross B. The term IDL is called the current element. And this equation gives the force on a current carrying conductor in a uniform magnetic field. And here this force perpendicular to both magnetic field and the length. This force depends on the total current and immaterial of the type of the charge carriers, whatever the type of charge carriers. Therefore, the magnitude of force on a current carrying conductor in a uniform magnetic field is F is equal to BIL sin theta, where B is the magnetic field, I is the current, L is the length of the conductor, and theta is the angle between length and magnetic field. If theta is 0 degrees Celsius, the magnitude of force on a current carrying conductor in uniform magnetic field is 0. That means if the angle between B and L is 0. So then F is 0, F is minimum. So then if theta is equal to 90 degree, that means if the angle between B and L is 90 degree, so then F is equal to maximum or F is equal to BIL. So here you can clearly follow the concept of force and a current carrying conductor in uniform magnetic field, and these are the references I have chosen. Thank you.